This video, look at transverse waves. Transverse waves are waves that occur perpendicular and oscillate perpendicular to the direction of travel. This is a classic example of a transverse wave, and you can see the direction of travel, which we can highlight with this arrow here, is going from the left-hand side to the right-hand side of your screen. And the waves coming off it are at 90 degrees. So the waves are oscillating perpendicular to the direction of travel. So perpendicular is actually a really important word that you learn and that you remember. And it just means it's at right angles to the direction of travel. And the direction of travel, we said, is going from left to right. And you'll see in the middle of the wave, the black line here, which we've labelled the undisputed position. So this black line, the undisputed position. Now, when we come to a transverse wave, you've got to be able to label it. And the top of the wave, we call the crest of the wave. Sometimes it is the peak. And the bottom of the wave we call the trough. Now, if we go from peak to peak, or even trough to trough, or any point of a wave to the exact same point on the next wave, so for example here, 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 any of those, that's our wavelength. Now our wavelength is really important when we come to do the calculations a little bit later on, and you'll sometimes see it, the little Greek letter lambda symbol. And then we also have to know and understand amplitude. Now, as I mentioned, this undisturbed position, the amplitude is from the undisturbed position to the peak or to the trough. It isn't from peak to trough. It's from the undisturbed position to the peak. So that's the amplitude. So we go from where we've got really zero displacement of the waves right to peak or to the trough where we have maximum displacement. So the amplitude is really a measurement of that maximum displacement. Now, you've got to be able to be familiar with the transverse wave, but also potentially give some examples. So some classic examples, which examples like to use, not only they can be obscure, a little bit like the strings on a guitar string, but also with water ripples, water waves, electromagnetic spectrum waves. So electromagnetic waves, they're, if you've not seen that yet, like radio waves and UV and light. But also, especially if you study geography, you might have come across the F wave. Now, the S wave is the secondary wave that we get in an earthquake. It's a bit slower than the P wave, but it only travels through solids. And so it does not travel through the core of the Earth. And it also suggests there that the mantle of the Earth has got solid type properties. So these are transverse waves. Be prepared to be able to label it, and also do some measurements from it, where we'll also look at in the next video of what calculations we need to be able to use these amplitude, potentially the wavelength for.